Hello guys, this knowledge module is a part of a topic of risk and rate of return. In this knowledge module, I'll explain what does it mean by the investment risk and how it is measured. Further, I'll also talk about the expected rate of return and how it is measured and how these both expected rate of return and risk are are related together, because you might have heard about this thing that higher the risk, higher the return. So I will try to establish the relationship in this knowledge module for your understanding. Further, we'll also talk about what does it mean by the risk averse investor, because it is considered that, in fact, not only considered, actually stock market, or any other market is basically dominated by the rationally thinking risk averse investors. So let's first define what does it mean by risk. Might be you have heard, or you might have considered that risk means that if you invest in something and there is a chance of losing something, that is basically there is a risk associated with that. So technically, it's not about it's not only about the loss when the risk to which the risk is associated. Uh, Even if there is something positive but it is uncertain, risk is associated with that. So technically, let's suppose that you are expecting something. Say you invested in a stock and you are expecting that the next year you'll get the 8% return. But there is also a chance that you might get more than that, and there is also a chance that you will get less than that. So there is an uncertainty. So there is a good uncertainty if the return, actually realized return after a year, will be more than the expected return, or there is also a chance that you will end up getting the realized return which is less than the expected return. So there is an uncertainty on both sides, a good uncertainty and the bad uncertainty. So as per the definition of the risk, technically anything which is all the uncertainty does not matter. You are on the good side of your expectation or you are on the bad side of the expectation, right? It's still uncertain, and that is basically that will come under the definition of the risk. So the risk is a chance that anything unexpected outcome will occur. So you expected that 8% return will come, but in case you will get 13%, you want that. It's extra. It's above your expectation, but still there is a risk, right? And yeah, that's different thing that you ignore that risk because you need anything above expectation. That's a good surprise to you. But technically, it's still a risk, because whatever is a chance which is like the chance that an unexpected outcome will occur, it will come under the definition of a risk. Yes, you do not need a bad side of the expectation, like where your rate of return, the actual rate of return, is less than the expected rate of return, say minus not minus 3, let's just say 3%. So you expected that 8% will be the return, but actually the return turn out to be 3%, so you are 5% short. You definitely don't want it. But anything if uh, which is not near to the expected, anything unexpected outcome, that will technically come under the under the definition of a risk. Now there is a probability distribution also. So probability distribution means that you have a range of different outcomes, and each of those outcome has a certain probability. For example, say tomorrow there is a chance of a rain, and there is a chance of having no rain, but the chance of having a rain is 40% and no rain is 60%. So there are two outcomes, and the probability is 40% and 60%. When you add up the probabilities, it should always be equal to 1. So zero point 0.4 plus 0.6 means 1. Or in terms of percentage, the one probability is actually the 100%. So the having a rain has a probability, in my example, 40%, or in other words 0.4, and the no rain is 60%, or in other words it's 0.6. But when we added up the probabilities, it should be equal to 1. It means that you are considering all the outcomes. You have not left any outcomes from the scenario. So just looking at this probability distribution, you can see that there is more chance of having no rain. It's a 60% chance, but it can also happen that when the tomorrow will come, actually there will be a rain, because there is a still 40% chance. So probability distribution will tell you that like what is the chances of a particular outcome to appear. And I will talk about also when it comes to the investment or the stock return, that how the probability distribution works. So let me take you over here in one of the example. Say if there is a stock A, and for some reason in the next year you are assuming that you did some analysis, or some financial analyst did the analysis, and he said that there is a 20% chance. This is the chance, this is the probability, this is PR, probability, and this is the return of the stock A. So there is a 20% chance, if you multiply it with 100 you will get 20, that the return next year of stock A will be 20%. But there are 40% chance that the return will be 10%, and again there is a 40% chance that the return will be 5%. You are talking about chances because you are talking about future, and you are not sure what thing will happen in future. It's just some analysis. You might have done the industry analysis, stock analysis. You also analyzed based on the past returns, but this is your like the probabilities, and this is the returns, or we otherwise in other ways we can say these are the outcomes, right? So if I'll make the probability distribution, I can see that on the x-axis I have the outcomes. So this is the 0%, 5%, 10%, 15%, 20%. So these are the outcomes, right? And over here we have the probabilities on the x-axis. So sorry, on the y-axis. This is y-axis, and this is the x-axis where we have the outcomes. So outcomes are over here, and then probabilities are on the y-axis. So you can see that the 5% return outcome has the associated probability of 40%. So there is a 40% chance, and then 10% return outcome has the probability of again 40%. There is with 15% outcome there is no probability because the probability is 0, so there is no graph over here. So and then you have a 20% return outcome, and its probability is also 20%. You can see over here, right? So this is actually the probability distribution. You can see that how we can define the probability using the graph, and obviously the higher the graph over here means higher is the chance of that particular outcome to happen, right? Now let's move ahead. If I give you two companies, so these are the two companies. One is the Martin Product, and the other one is US Electric. So Martin Product is a company which is basically specialized in data transmission. It has a data transmission expertise, and the US Electric is the utility company. The data transmission companies basically move with the economic cycle, so their business is very cyclical. If the economy is doing good, they do good. If the economy is doing bad, they do bad. The US Electric is a utility company, and the utilities companies have relatively stable cash inflows, because does not matter if the economy is doing good or bad, all the people need the electricity in their houses, so they keep using the the services of the utilities company. And so that's why it does not matter if it's a booming economy or it's not that much booming economy, usually their business do not suffer, and they do, but not by that much. So their income or the cash inflow of the cash is relatively stable. Their income stream is relatively stable, in other words. So with that background of these two companies, there was an analyst. He started analyzing that over the next in the future, or in the next 1 year, there is 20% chance of having the boom. So there is a 20% chance that there will be a boom economy, 50% chance there will be a normal economy, right? So and then there is a 30% chance that there will be a recession. Again, you need to add all the probabilities, and all probabilities should be equal to 1. It means that you are not leaving any outcome. All the outcomes are getting considered over here. Now, when there is a 20% chance of when there will be a boom economy, we can see that the Martin return will be 110%. And it, because we know that it's a very cyclical, this company is having a this company is having a very cyclical business, so that's why they they move usually with the economy. So there is a 110% chance. So when the economy is doing good, the company is also doing great. When it's a normal economy, it has a 22% return. When it will be a recession, there will be a loss of investing in this stock of Martin products. It will be a minus 60%. If you see the US Electric, it's relatively stable in all these three, the state of the economies, the state of the economy. When it will be a boom, it will be giving us 20%. In normal economy, it will be giving us 16%, and in the recession, it is giving us the 10%. From where do we get this number? At this point, you just need to consider this number, that these numbers are given to you, but actually the analyst maybe based on their past history, that during the boom years and normal years and recession year, how the company generated the return. They might have used that data, plus they also analyze the industry and what is basically future is offering to the industry and the company. Based on many factors, the analyst came to this number. But to you guys, at this time, we are not trying to find that how this number we have computed. Main thing is these numbers are right now given to you, and we need to do the calculation based on these numbers. Now, if these are all the outcomes, right, and if I'll ask you what would be the expected return next year, what, because the analyst is showing you that this is the probabilities of the outcome, and these are the outcomes of the Martin product, and these are the outcomes of the US Electric. So when it is a boom economy, the Martin product will give us 110%, and the US Electric will give us 20%. But the probability of that of the economy to get flourished, or of a boom, or the boom economy, is just 20%. So there is a chance that other states can occur as well. So in that case, we calculate the expected return. And how we find the expected return? We simply multiply the probability with the outcome. So 0.2 multiplied by 110%. Right now, I'm just talking about the Martin product. Then 0.5 multiplied by 22%, 0.3 multiplied by minus 60%, and add them all together. So in other words, I'm taking the weighted average of the return, or in other words, weighted average of the outcomes of each stock, where weight is equal to the probability. So you can see that that in this case, what I will do, I will simply go and multiply 0.2 with I need to check what was I think 110%. Likewise 0%, 0.5 when it will be normal economy multiplied by the 22% plus the 0.3, the chance of having a recession, multiplied by minus 60%, right? And if you'll calculate it, you will get your answer. Like I already have worked on this question before, because when I was preparing the lecture, so I got it the 15%. In the same way, so this is for the Martin product, right? This is for the Martin product. In the same way, we can do it for the US electric as well. We can also use the calculator for that purpose. So if you'll go into the BA2 Texas Instrument calculator, go into the second data, second clear, all the outcomes will come as x01. So x01, x02, x03s, and the associated probabilities will be fed as y01, y02, y03, and they will be fed not in decimals but in percentage. So let's do it. So second data, always clear it, second clear. And what is the data? My data is 110%. When there will be a boom economy, this will be the outcome. Enter, go down, and what is the probability of that outcome to occur? It's 20%, right? Then we have 22%. Just let's double check it, so I do not want to do any mistake. So 22%, and then what is the probability of that 22% to happen? It's 50%, right? 0.5 multiplied by 100 will give you 50%. Then I have this x03, which is this one, and this is minus 60%. Enter. And what is the probability of minus 60%? It's 30%, right? This one, this 0.3 multiplied by 100, it will give us the 30%, and enter, right? So always double check your numbers. Sometimes there is a chance that you can do the mistake. I do not want to do that mistake. 110% with 20% probability, 20% probability, 22% when the economy will be normal. So that the normal state, the chance of having a normal state is the 50%, and that the outcome related to the normal economy is 22%. So the Martin product will produce 22% in the if the economy will be normal. And go down, and yes, its chance is 50%, which analyst has already measured based on some analysis. Maybe he has done the economy analysis, company analysis, and industry analysis, which is beyond the scope of this more knowledge module. And then minus 60%, and why the chance is 30% of having the recession, and during the recession the outcome will be minus 60%, which came as the x03, right? Now it's only one variable. The variable is trying to find the expected return, that what would be the expected return of the Martin product in the next year, right? So go into the second stats. This is one variable, so 1v means one variable, so we'll only check the one variable. So the x bar over here is the expected return. So this is actually the expected return. Just give me a second, I do not want to cancel it. So this is the expected return, and usually it will be calculated at the Martin product, and this is hat expected return 15%. So the next year the chance of having the Martin product return based on these three outcomes, and the given the condition, like the probability of the outcome is 15%. So now you can pause the video over here, see if you can do the calculation for the US electric. Remember, your x01 will be 20% and y01 will be also 20% over here, and then x02 will be 16% and y02 will be 50%. x03 will be 10% and y03 will be 30%. And if you do, you'll also find that its expected return is also 15%. So I hope so you also got 15% for US Electric. So what we have found that expected return based on this data and this probability distribution, the expectation about the return of the Martin product next year is 15% and also the same 15% for US Electric. But just eyeballing these numbers, you can see that there is a lot more variation, right? If it is a boom, you can get rich by investing in the Martin product, but you cannot get rich if you invest in the US Electric because there is not much variation. Like you will just get 20%, right? But if it will be a recession, you will actually lose 60%. So it means if you have invested the $100, you will end up just having $40 next year. If you see the US Electric, it even under the recession, it will still give you the 10%, means your $100 investment, or even under recession in US Electric will produce $110 for you, where $100 is the original investment and $10 is basically the return which you'll get on your investment. So you can see that even the expected rate of return is the same for both of these stocks, but there could be much more risk. This this variation, increased variation in between the uncertainty or the outcome. In other words, over here, this uncertain outcome and the variation of the uncertain outcome basically pose a great risk, and that is where we'll come with the concept of standard deviation, and we'll look into it very quickly in next few slides. Now the expected rate of return, it's simply the weighted average of the outcome where the weights are the probabilities, right? This formula we implemented over here, this one, right? So this was the formula I simply implemented. This formula I implemented over here. I multiplied the probability of each outcome. This was the outcome, this was the probability associated with that outcome, and I did it for all of them, all the outcomes, and simply added them together, and this is how I got 15%. And I also showed that it's much more easy to do it on the calculator. You do not have to do it manually, and calculator will do it for you, right? Now coming back to the topic, how we can find the risk. We know just eyeballing these numbers, there is a lot more risk in the case of Martin. They both are giving, Martin product stock and US Electric stock is giving us 15% expected return for next year. But you can see, say if like you have a recession, you will lose a lot in case of Martin. If it's a boom, you can gain a lot in case of Martin. But in case of the US Electric, there is a stable, very much stable return. So there is clearly we can see there is a less risk in case of US Electric, does not matter what is the outcome. But in case of Martin product, there is much more risk because the difference between the uncertain outcomes is very big, right? At one end it's minus 60%, and at another end it's 110%. So here comes the concept of the standard deviation, and using the same thing the way you have done, if you go further down, this is the standard deviation. Whenever there is a probability involved, this sigma you have to look. So because there was a probability involved in this question, right, and you have like feed all the number, you fed all the number in the data, like all this number which we have earlier done, and we went to the statistics, and within the statistics we have to look into one variable, because the variable which we are looking at is the return and the standard deviation, in fact the return of the the Martin product only at this time. This stock, right? I'm assuming that you will replicate all these things on US Electric by yourself and find your numbers, right? So if I'll go down, this was the expected return, and this is the standard deviation as well, but when there is no probability involved, right? So this is a simple standard deviation. We have to look whenever there is a probability involved. This is an important concept to remember, right? Whenever there is a probability involved, we go into the sigma, this one, right? So what is the standard deviation? 59.30. So 59.30 is the standard deviation, and this number is simply means what is the like the dispersion from the expected return. So if this number is high, the higher this number, higher is the risk. Obviously, higher is the risk for investment in this stock. This is important thing to remember, and we can see that there are three outcomes, and these three outcomes are obviously uncertain, and but the difference between these uncertain numbers is very big in case of Martin product compared to the US Electric. So this is the standard deviation 59.30. It's very easy to do it with the calculator as we have just seen it, but if you want to do it with the formula, so here is the formula. Let me take you to the formula very quickly. So here is the formula. First, you have to find the expected return, which was the 15%. What is this? R1. For the Martin product, the first outcome is R1, which is $110. So R2 is 22%, R3 is minus 60%, right? So this is PR1, probability 1, or probability of the first outcome, which is 20%, probability of the second outcome, PR2, which is 50%. This is the PR3, probability of the third outcome, right? So if you see, this is the formula for the standard deviation. So R1, 110 minus 15%, take its square and multiply it with its probability, which was 20%, plus R2, which was 22%, minus the 15%, or like R hat, which is the expected return, raised to the power 2, multiply by the PR2, probability of the second outcome, and you keep doing it for all the outcome. In case of Martin product, because we have only the three outcomes, then we have the last term as only R3 minus expected return 15% raised to the power t raised to the power 2, multiply with the probability of the third outcome, which was, I guess, 30%, right? And if you then finally take its square root, you will get the standard deviation. If you do not take the square root, let's suppose if you only evaluate the things like this, evaluate these terms and do not take its square root, then that is called variance, right? And this is what you have. If you do it manually, you will find out that for the first term will give you inside the square root, the first term will give you 1805, the second term will give you 24.5, the third term will give you 1687.5. If you add them all together before taking the square root, you have variance, and or in other words, you also say it's sigma square, that is 3517. But once you take its under root, like this is this thing, like is the under root, this like this, this is like what you do, this is the square root or the under root. Once you take it, you will come to the standard deviation. So this is what the I have done over here, right? So this answer will be 59.3%. So the expected return of the Martin product based on this data of all this probability and the probabilities data and the outcome of the like three possible outcomes in case of three outcomes in is the 15%, that's the expected return, and the standard deviation is 59.3%. And again, the bigger the this number, this one, it means more this stock is much risky. So in case there is an other stock which is giving you the same 15%, but its standard expected return, it is giving you the same expected return of 15%, then this but the standard deviation is 110, it means that stock is more risky because the dispersion of the outcomes is much bigger for that stock. Now, contrary to that, if there is another stock with 15% return, expected return, but the standard deviation is say 5%, only 5%. In that case, the stock with the standard deviation of the 5% but same expected return is much less risky. It's actually not risky at all. It's like the risk level for investing in that stock is much lesser. So, or the better word is it's lesser. So let us do it now the same thing with the US product, right? And let me, in fact, US Electric, its name is US Electric, right? This thing. So let's do it very quickly and see that what is the standard deviation. So we are comparing the Martin product and US Electric. So I'm going into the second data. I'm clearing my previous buffer, and now let's start feeding in the US Electric number. So I have 20% with the 20%. So this one, then Y1 is also 20%. What this 16% is my X2, Y2 is 50%, 10% is my X3 for the US Electric, and 30% is my probability of having recession, right, for the US Electric. So just quickly want to just double check the data, and I can see that data seems to be correct, right? Yes. So let's go into the stats. What is my expected return for US Electric? The same 15% for US Electric. It is the same based on this data for the Martin product as well. And then I have to go to the sigma because the probabilities are involved. So we have to go into the sigma, this one. So I can see it's 3.61%. So look over here. What a big difference. It's a big difference in case of the Martin product. I got my expected return, right, R hat is equal to 15%, right? But my standard deviation of the return of the Martin product is 59.3%, I guess so, right? In case of the US Electric, right, my expected return is the same 15%, but my risk standard deviation, in other words, is how much? It is 3. What was the number? 3.61%. This is much less. So it's no brainer that with the same expected return, if someone will ask me where to invest, I will go with the US Electric. And why I'll go that? Because its risk, the measure of the risk, which is the standard deviation of the return, expected return, is much less for the US Electric compared to the Martin product. The variation in the expected return based on the probability distribution is much high for the Martin product, and it is very low for the US Electric. So I'll feel safer with the same expected return. So expected return is not changing. I will feel much safer to go and do the investment in the US Electric rather doing the investment in the Martin product. Now, if we do not have a probability distribution and we are just analyzing the past data, we can obviously take their average. Say if there is another stock and we were sitting at the end of the or at the start of the 2017 in January, and we have these data available for the past 6 years for that stock. In 2011, the stock generated 20%, 2012 it generated 15%, 13, 23%, and all the way like for 14, 16%, 2015, 13%, 2016, -5%. How can we summarize these returns? Remember, these are now, we are not talking about the future, we are just analyzing the past data. In that case, you add up all these data and divide them with the total number of the return. So and you will get actually the average return, right? Average return. uh, and also you can see there is a variation. The return actually kept changing over the last 6 years. And there is also a standard deviation, but now the standard deviation which you'll use will be different. So let me show you over here very quickly what how I'll proceed over here. So I'll go into the second data, and second clear. Obviously from the previous calculation I have to clear the memory of the registers. So 20%, in that case y1 will remain 1. I'll not change it, because if there will be a probability involved, then I have to give the probability. But the probability is usually given for the return which we are expecting in the future. The difference over here is the data is from the past and we are only analyzing the past performance, right? And then what is my x2? It's 17%. y2 will remain 1, because there is no probability involved over here. We are not talking about the future, we are just analyzing the past data. 23, enter. Then 1 is the same for y03, and x03 is 16%, 13% for the 2015 return, and -5% is for the 2016 return. So there are 6 years, right? So I just want to double check the numbers again. So always double check your numbers, right? Now go again into the stat. Again we are in the one variable x bar, which is if you add all these number and divide by 6, because there are 6 data points, you will get 14% mean. But now because it's about the historic data, you'll not go and try to find the sigma, but in fact this is the standard deviation over here. Like so this is 14%, right? And then your simple standard deviation based on the past data is actually the return is 9.9%. So 9.92%, or you can say 9.9%, right? I do not have a pencil right now. So 9.9%. So it's relatively near to 9.06, but remember, this standard deviation you will always consider when there is a probability involved. When there is no probability involved, means we are analyzing only the historic numbers, then this standard deviation will consider from the calculator. And the formula is this much, which this is the formula which you can actually use if you want to do it manually. But I will obviously recommend you and highly recommend you to use the calculator, because that will make the calculation much easy for you, and also there is less chances to do any mistakes in the calculation.